We will take another example to further practice the use of interfaces. Here is a problem statement. Write a class data comparer that provides a service of finding the highest, lowest, and average values from an array of values. The values can be of wide variety of types, like student or city. Write an interface measurable that should be implemented by any class that wants to use the services of data comparer class. Modify the student and city classes from the arrays exercise to implement measurable. Let us first revisit the student object score comparer class that we implemented in the arrays exercise. The find highest scorer method accepts an array of student objects and then finds out the student who has the highest score by comparing all the student scores. If we had an array of city objects and wanted to find out the city with highest temperature, we would need another method that accepts an array of city objects. For every different type of array, we need to define a different method, although the logic for the comparison is exactly the same. Only what is different is the type of object, either student or city, and the value that has to be compared, either score or temperature. The requirement is to design a class that can be used to compare values of different types. This is a scenario of algorithm reuse. Let us explore the use of interfaces for achieving this. Let's define a class data comparer. It implements the method findHighest, which accepts an array of objects. This method should accept an array of different types of objects like student and city. How is that possible, as student and city are very different objects? Well, that doesn't matter to us, as we just want to compare their values, if you remember the concept of polymorphism. Polymorphism is the ability to use a reference of a superclass to refer to an object of a subclass. In the earlier examples, we have seen methods that are declared with a reference type of supertype as argument can accept an object type of subclass. The superclass can be a class or an interface. Since student and city are very different objects, they cannot extend from the same class, but they can implement the same interface that will make student and city classes capable of being compared using the data comparer class. So, we will first define an interface measurable. It defines a single method getValue that returns a double value. Now, let's make student class implement measurable and implement the getValue method. The getValue method of the student class should return the score, as score is what has to be measured. Similarly, city class will implement measurable, and in getValue method, it will return the temperature value. Now, let's modify the findHighest method of data comparer class to accept an array of measurable objects. Now, both student and city arrays can be passed to this method as both implement the measurable interface. We will take first element of measurable array into a measurable object. Instead of calling getScore method, we will call the getValue method. The getValue method will return a score value for a student object and temperature value for a city object. Similarly, the other methods can be modified. In the test class, we create an array of cities and pass it to the findHighest, findLowest, and findAverage methods of data comparer object. Let's run the program. The program runs successfully. Similarly, we can use the comparer to compare student objects. In this video, we learned about the use of interfaces. You should now attempt the programming challenge.